today we will discuss some typical types of algebraic integration. The first type we'll discuss type when e to the power x is multiplied with addition of two functions. One function is derivative of the other. That means e to the power x multiplied with the function fx and its derivative. Like example, e to the power x multiplied with x square plus 2x. This type of problem. Because if you watch x square, then derivative of x square is 2x. So if I say fx is x square, then f dash x, the derivative of fx is 2x. So this type, how to solve this type of problem? In this type of problems, we have one very general principle which can be used as a idea formula, but we are not going to use the formula, we will solve it. There is a substitution concept in this type of problem. Like I am having a question, e to the power x, x log x plus 1 by x dx. You have to solve this. How to integrate? If I watch the question very carefully, then we are finding that e to the power x separated x log x by x plus 1 by x. Now what we are finding that e to the power x, then bracket x cancelled out, it is only log x plus 1 by x. So now we watch the problem, e to the power x into fx plus f dash x. The rule of this type is always to substitute. What to substitute? E to the power x fx to be substituted. That means we will write let always. We will always let, the rule of this type is let t is equal to e to the power x into the function. Which is function? Function is log x. Because if you differentiate it, f dash x, it is 1 by x. So now we are finding the concept of the typical type. Log x plus 1 by x. Log x is fx, 1 by x is derivative of fx, that is f dash x. So now we will follow the rule, and the rule is to take the substitution as t into fx, t is equal to e to the power x into fx. Sorry. Now what we will be doing? dt. We will differentiate that t, dt will be product rule, u into v for derivative. E to the power x differentiation is e to the power x, fx is left alone, left as it is, and then e to the power x into derivative of fx is f dash x. This part will be multiplied with dx because we are differentiating with x. So now if you watch this one, that is e to the power x into log x, because fx is log x, plus e to the power x into 1 by x. So we can take common. What is the common? E to the power x into log x. Actually the rule is e to the power x into log x. In this case, when you differentiate e to the power x, fx is log x and e to the power x into f dash x is 1 by x. So take e to the power x common. So what you are finding? Log x plus 1 by x. So now go back to the problem. Look at the problem. What is the problem? Problem is this, the whole one. E to the power x into log x plus 1 by x. So your answer, your idea will be, that integration will be this part. If you look at the question, this part, the whole one is now dt. And what is there? It is 1. So dt is 1 dt, and the result is t only. So the t, what you have taken as t? E to the power x log x. So the answer is e to the power x log x. So whenever we find this type of problems, any type of problems like this, we have a simple concept of taking the function e to the power x with log x or whatever it is. Like one more problem I can show, similar type, this under this typical type, e to the power x into 1 by x minus 1 by x square. So if you watch closely, derivative of 1 by x, e to the power x into 1 by x derivative is 1 by x square minus. That means if I take t is equal to e to the power x into 1 by x. Now we are differentiating dt. Differentiation is product, 1 by x is as it is, e to the power x derivative is e to the power x plus e to the power x is now left, 1 by x derivative is minus 1 by x square, the whole thing multiplied with dx. Now we take e to the power x common to get 1 by x minus 1 by x square dx. So finally what you are finding is that this is the problem, and that problem is now dt. So what you will be now doing, we will be doing only dt. Only dt because now the whole integration is converted to dt. So your answer will be t, because 1 dt is t plus c, and t is e to the power x into 1 by x. But there are some tricky questions, few, where we have to adjust the expression. Expression means, like this question is very famous one. It's a very famous question. This type of question is very common type, like integration x e to the power x by x plus 1 whole square. We cannot solve it, but we have a thought. If I have 1 plus 1 here, because e to the power x into x by x plus 1 whole square is the problem. But what you are finding that we are not having two expressions added, but I can adjust. If I add 1 and then subtract 1, then automatically that x remains as x. But this concept, this idea, we can separate. How to separate? X plus 1 by x plus 1 whole square minus 1 by x plus 1 whole square. That means what you are getting in the integration part, e to the power x into x plus 1 by x plus 1 whole square minus x plus 1 whole square dx. Okay, so that is the expression we can have. Now if you look, it will be cancelled. X plus 1 is cancelled in that whole square part. So it is e to the power x 1 by x plus 1 minus 1 by x plus 1 whole square dx. This is the integration of the whole thing. Now you watch. This is fx, that is f dash x. Because derivative of 1 by x plus 1 is minus 1 by x plus 1 whole square. So if I take t is equal to e to the power x into 1 by x plus 1, then dt will be the differentiation product rule. 1 by x plus 1 as it is, e to the power x is e to the power x plus e to the power x into 1 by x plus 1 derivative is minus. Yes, this is the idea. That is the idea, because derivative of the expression is this. Now if you watch, if I take e to the power x common, then what you are getting? You are getting the whole expression. So this type of problems are, now we have the whole expression. So what's the result? How to solve it? The solution of this problem will be integration only dt. So in all this problem we are finding, ultimately we are getting 1 dt, and 1 dt is t. So your answer is e to the power x by x plus 1 plus c as the constant. So this is a type. Now the second type what I want to discuss is a little bit, not as any particular heading, but we have an idea, and the idea is like this. This is a type 2. So type 2 means this is not a particular problem, it is a typical type. E to the power x, if I have this question, e to the power x by this, then I can integrate. Why? Because we can take t. Look at this type. We can take t and we will get e to the power x dx, but this e to the power x is not there. Think it. What is the problem? This e to the power x is there, then we have the easiest part. If you have e to the power x this, then it will be easy, because we will take t is the denominator. Denominator is t, then we will get dt is the numerator. We will get the answer, but it is not. So what to do? We have an idea. What we can do, we can take e to the power x common from the denominator. From the denominator we can take e to the power x common, but can't be. Yes, we can. This e to the power x common means 1. This 1 will become 1 by e to the power x, because 1 by e to the power x and e to the power x will be cancelled, will become 1. Now e to the power x will be taken in the numerator. Yes, this is the idea we have. Some students are so quickly find it, they can write directly this one. Now you have your idea. You can take t as a denominator. This is a type. There are many questions of this type. Now you can directly put let t is equal to 1 plus e to the power minus x. And dt will be, the derivative of this will be 1 is derivative 0 and e to the power minus x is minus e to the power minus x. Minus e to the power minus x. That minus will take this side, multiplying minus there, and it is. So now look at the numerator. I think numerator is this one. So your problem is now minus dt by t. Why? Because this part is the numerator after taking common, and this is minus dt, and the denominator is t. So you are getting t to the power minus 1 dt, which is log t. And what is t? T is this expression, minus log 1 plus e to the power minus x plus c. So this is your answer. So what you are finding in these problems, all these problems we have, that's typical one. The similar question we can have, similar, like this one. Dx by 2 to the power x by 2 plus 1. Now the same problem, no numerator is there. How to solve it? You can take one thing, 2 to the power x by 2 I can take common. Why? Because if I watch this expression, this is root 2 to the power x. So if I take 2 to the power x by 2 common, then this will become 1 and this will become 1 by 2 to the power x by 2. Now this will be taken in the numerator and denominator is 1 plus 2 to the power minus x by 2. Now you have your benefit. You can take the 2 denominator as t. Now we can take denominator as t. So if I take let t is equal to 1 plus 2 to the power minus x by 2, then what we are finding is dt is 2 to the power minus x by 2, that is minus half, because there is a minus, 2 to the power minus x by 2 into log t. This is the formula for a to the power x derivative. A to the power x derivative is a to the power x, but this is minus, that's why minus, but there is a half. That's why minus half 2 to the power minus x by 2 into log 2 dx. Derivative of a to the power x is log a multiplied here. So now we are finding this portion is not there. That means we are finding 2 dt by log 2 after multiplying this one to this side and log 2 that side minus this side, 2 to the power minus x by 2 dx. So now coming back to the problem, we are coming back to the problem to get 1 by t minus 2 dt by log 2. So you can take minus 2 dt, 2 by log 2 outside and t to the power minus 1. So now we can integrate t to the power minus 1 as log t. Now we can integrate 2 to the power minus 1 as log t. So 2 by log 2 into log t plus c. And now you are putting the value of t, and t is your derived base e always. So this is the answer for this question. These are another typical type. Another type of algebra. We can express any fraction into two fractions, addition or subtraction type. We can express any fraction as two fractions in addition or subtraction type. Then what is the idea? Normal idea, if you have only dx in the numerator, fraction, we call rational fraction. Third type. There are many other types, but I am just discussing the basic algebraic type. Third type is if you have dx by two factors x minus a into x minus b or x plus minus a. What is the idea? See this two, the two factors. What is the difference? Take the difference. So the rule will be 1 by the difference of the two, then difference of the two factors divided by this one. This is the rule. It's not very clear idea to see this one. This idea is not clear. I have to give an example. This idea will be doing. you have to give an example. Now I am taking an example. And the example is this type. And the example is dx by x plus 2 into x minus 1. Now if you watch this 2, the difference of the two, x plus 2 minus x minus 1, the difference is 3. 2 plus 1. Now what we'll do, we'll write 1 by the difference into 3 dx by whatever the factor is. Now look, what is 3? 3 is difference of the 2. What is 3? 3 is difference of the 2. That means we can write 1 by 3 x plus 2 minus x minus 1 divided by this one. This is a very common type of problems we can do if you can factorize the denominator this type. Linear factors, it is called linear factors. Now I'll separate. Now I'll separate the expression in two parts. Now I'll separate this expression in two parts. 1 by 3 x by plus 2 by x plus 2 into x minus 1 and dx. This will be cancelled. Minus 1 by 3 is outside. X minus 1 by x plus 2 into x minus 1 dx. Now watch. This x minus 1 is cancelled out. This x minus 2 is cancelled out. X minus 2 cancelled out. Here x minus 1 cancelled out. So this is 1/3 dx by x minus 1, the first time. The second time again 1/3, because opening the bracket we are getting 1/3 both, dx by x plus 2. Now if you see, if you differentiate x minus 1, it will become dx. If you differentiate x plus 2, it will become dx. So that is dx by the expression. So it is dt by t. In other words, this is dt by t. So we can say 1/3 and then log. Directly I can get, because x minus 1, log x minus 1, if you take, this is coming from 1 by x, but it's x minus 1, that's why we are writing log x minus 1. If you take this is log x plus 2. Both are mod, and then plus c. So this type of problems we can have in algebra, typical type. There are some more typical types. In the next classes we will discuss some more.